Example 3. Instrument calibration is very important to maintain the accuracy of the measurement. The measurement by a calibrated instrument is more accurate. Let me use graduated cylinder calibration as an example to explain. In plain words, calibrating a graduated cylinder at 2 milliliter mark means that we do not believe the volume at 2 milliliter mark as shown in the figure is 2.00 milliliter, and we want to know its volume more accurately. From what we have learned in class, the volume of the liquid in the graduated cylinder should be 2.00 milliliter. If we want to calibrate the 2 milliliter mark, that means we don't think the volume of the liquid in the graduated cylinder right now is 2.00 milliliter. We want to get a more accurate volume reading. The following problem explains how to calibrate the graduated cylinder at 2 milliliter mark. The mass of an empty graduated cylinder is 26.837 gram. When water is added to the 2 milliliter mark of a graduated cylinder, the total mass is 28.784 gram. Then water is dumped out and the graduated cylinder is cleaned and dried. An unknown liquid is added to the same mark. The total mass is 28.479 gram. If the density of water is 0.99928 gram per milliliter, what is the density of the unknown liquid? When we are given a calculation problem, the first step is always to summarize the most important information. The most important information includes numbers with units, what we are looking for, and balanced chemical equations if there are chemical reactions in the problem. When we read this problem, we have three different methods. Therefore, to draw a simple illustration will help us to distinguish them. Theoretically, I should draw three identical graduated cylinders, but it's beyond my capability. Just remember, these three graduated cylinders are the same. Well, you may have already noticed I used three similar symbols to represent the three different masses. I changed M0 to mgc because mgc is easier to understand. It is a mass of the graduated cylinder. Similarly, we use mgc plus water to represent the mass of the graduated cylinder plus water. Similarly, we use mgc plus ul to represent the mass of the graduated cylinder and the unknown liquid together. The next step is to analyze. We want to find the path from what we are given to what we are looking for. Let's see what we can get directly. When I see directly, I mean we can get the result by a single step calculation. Since we know the mass of the graduated cylinder and the mass of the graduated cylinder and water together, we can get the mass of the water only. Similarly, we can calculate the mass of the unknown liquid only. Well, after we get the mass of the water only, since we know the density of the water, we can calculate the volume of the water. From the problem, we know that we add the unknown liquid to the same mark as when we add the water. Therefore, the volume of the unknown liquid should be equal to the volume of the water. Then, let's see what we are looking for. We are looking for the density of the unknown liquid. We know the formula to calculate the density of the unknown liquid. The three-line symbol represents this is a definition. From our calculation, we already know the volume of the unknown liquid if we do this step by step. We can also calculate the mass of the unknown liquid from this step. Well, when we first look at this map, it looks a little messy. Now let me tell you the trick how to use this map. We always start from places whenever there's no arrows pointing to. Then we will follow the arrows to finally reach what we are looking for. This can be the first step. This can be the second step. This can be our third step. This can be the fourth step. This can be the last step, which is step 5. Next, let me show you the work of all steps. From our calculation, the volume at 2 milliliter mark is 1.948 milliliter, which indicates our calibration is necessary.